Hi everyone. So today we will be learning about how to solve for the sampling distribution of the mean. So in this lesson, you're going to learn how to get the probability of a random sample. So it's not a random variable na, but a random sample. So to refresh, you know that a population has samples, right? So dili ta maka kuha I mean it's possible to get the data of the population, but it can be costly and time consuming. But instead, researchers will get the samples and samples denoted by letter N. So they take an unbiased random sampling. They take samples from the N population, denoted by capital N. So sampling distribution will tell us if kaniba na N samples is a good representative of the population. So um, there are two key points that you should notice in the examples in this video. So since this is a sampling distribution of the mean, there are two types, with replacement or without replacement. To illustrate an example, unsay bit pasabot aning with replacement. Imagine imagine ang lotto. I think there are the lotto needs what 1, 2, 3, 4, 5, 6, right? 6 ka ano um 6 ka numbers, let's say from 1 to 65, ah sorry 65. So unsa yung probability na kani kay 0 to 1 to 65? Kung moingon kag without replacement, for example, ang nigawas na number is, let's say, 24. When you talk about without replacement, meaning, si 24, dili siya pwede mo appear again. So, ang imong possible nga values for 1, 2, 3, 4, 5 is 0, 1 to 23 and 25 to 65. Kay without replacement man siya. But if with replacement, meaning ana, 24, pwede pa siya mo appear sa remaining 5 ka slots. Okay? So, that's what with replacement or without replacement means. So, in the examples, we need to know what's the probability of that number occurring for that instance. So let's go ahead and analyze this problem here. It says here that given the population 1, 1, 1, 3, 4, 5, 6, 6, 6, and 7, find the probability that a random sample of size 36 selected with replacement will yield a sample mean greater than 3.8 but less than 4.5 if the mean is measured to the nearest tenth. So, it's specified here that ang imohang average or imong mean kay measured in the nearest tenth. Okay? So, uh, okay, so, first, kay we need to go back to what we've learned in chapter 1, finding the probability. So, okay, let's go back here. So, remember this. Sub I, we have probability of x equals x sub I. And then x sub I times the probability of x equals x sub I. to the x minus mu squared times probability of x equals x sub I. I hope you still remember this one. So, if you go back, unsay possible values na to? 1, 3, 4, 5, 6, and 7. So, let's plug that out. 1, 3, 4, 5, 6, and 7. Now, the question is, what is the probability na mo appear si 1? B, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ka, 10 iyahang capital N. I mean, given the population here. So, pila siya, be? Ikapila mo appear si 1. It can appear 3 over 10. Right? 3 over 10. Or 0.3. And then, we will have this one. 3. So, kaysa 3 only appeared once. So, 1 over 10 or 0.1. And so on. How about 4, 5? So, 4, 5, and 7 only appears 1. So, or 0.1 or 0.1. And C6, if you go back, appeared 3 times. 3 over 10 or 3. Okay. So these are the probabilities that these values 1, 3, 4, 1, 3, 4, 5, 6 will appear in n equals 10. So we multiply that value to its probability. We have 0 0.3, 0 0.3, 0 0.4, 0 0.5, 1.8, and 0.7. And sorry, I think naglaktaw ko dere. Is there an eraser for this? Lang. This is actually wrong. Ako na lang siya sa pawan og white. This one. Sorry. This one. Kulang pa siya. X minus mu squared times probability that x equals x sub I. Okay. Okay. You can get the mean by adding the values here. So, mu here is what? Since this is a sampling distribution, your symbol for the mean should be mu x sub bar. The x sub bar here represents that it's from a sample. It's from a sampling distribution. So this is mu equals mu sub x bar is equal to 4. Then 1 minus 4, 3 squared. 1 minus 4 is negative 3, then you squared it, you have 9. And so on, you have these values. 3 minus 4 squared, it's 0. 5 minus 4 squared is 1. 6 minus 4 squared is 4. And 7 minus 4 squared is, what, 9 again. Then you multiply the values here times its probability. So you should have 0.3 times 9. This one times this one equals 2.7. And you do that for everything. 0.1, 0, 1. No. 0.1 again. Then 1.2, then 0.9. And if you will get the sum of this, you will have the variance x sub bar. Sigma squared x sub bar. And if you add this, you have this one, 5. So, since you now have what? X sub bar is normally distributed with mean mu 4 and what? Standard deviation of 5. Okay, so actually ang definition for this is n mu sub x bar over sigma squared x bar. Right? I hope na nagets ninyo ni. So let's go back to the problem. It says here that it is what? With the replacement. With replacement. So, so, you should remember this, ha? Uh, if with replacement siya, yeah, right? If the sampling distribution in with replacement is mu sub, I mean sampling distribution mean is this. But if mingon siya na with replacement, ang imuhang standard deviation is what? Square root of sigma squared over n. So I think I've made a mistake here. This is the variance, not the standard deviation. So I think, no, ako sa na-erase. This is actually still wrong. This is not the variance, ha. Wala pa standard deviation. Lang. That's correct. This is the variance, but what you need here is the standard deviation. Okay, let's leave that as blank for now. Okay, so now we have what? Square root of what's our excuse me. We have our variance is 5 x sigma squared x sub x bar is 5 over what is our n? What is our sample size? Our sample size is what? 36. So this is over 36 or 0.3727. And we will go back here. So this is actually what? 0.3727. And ay sa magkakon, wala pa na siya nahuman. Remember that ang yung ipapangita is probability that a random sample size of 36 selected with replacement will yield a sample mean greater than 3.8 but less than 4.5 if the mean is measured to the nearest tenth. So we're not yet over. Okay? So if we recall, yung ipangita is the probability that the sample mean is greater than 3.8, but less than 4.5. That's what the problem is all about. So from here, we need to convert this to probability of z something here. You should look at your tables. But please recall, guys, what I told you during the face-to-face classes. You need to get the what? You need to get the z-scores. In where z-score is x minus x bar for sampling distribution, x bar minus mu over sigma over what? Sigma x bar. So for z1, let's say this is z1, our x bar here is actually what? 4.5 minus mean, the one we got is 4, divided by 0.373. So this is what? Ano lang. Z1 is smaller. This is your z1, 3.8. So this is negative 0.536. Your z2, on the other hand, is 4.5. This is your value for x bar, minus 4 over 0.373. And this is 1.34. Therefore, this is z is greater than 0.536 but less than 1.34. Or should I say probability that z is less than 1.34 minus probability that c is less than negative 0.536. Use your table 2 to find 1.34, and it should say that 1.34 is 0.9099, and this is 0.2946 or 0.6153 or 61.53. So I hope guys na kabal na mo mangitaan. Okay, so let's okay, so unsa man, I hope na you should ask your classmates or check for yourself on how we got this. Use the standard normal table. Okay, so this is what we're looking for. This is the final answer. But in our class, I will ask you to find the area as well. Find the graph. So our mean here is what? Given 4. Right? Our given mean is 4. That's what we solve for the probability distribution. And then 4.5 should, if this is 5, 4.5 should be somewhere here. And then 3.8 is somewhere here. So the shaded area, the area that we're looking for, is this one. Phew. Okay. So in a minute I'll give you an example of without replacement. I'll just pause this video for now. Okay, this is example number 2. So given the population, again 111, 345, 666, and 7, find the mean and standard deviation for the sampling means for sample size of 4, selected at random without replacement. So if you can recall, same repetition na values para dili ko mag-usab og table, but the process is still the same. So you get the probability for this to get the mean. Okay, but for the standard deviation, it's a different story. Kay naman, this is without replacement. So for without replacement, your mean is still mean x sub bar, but your standard deviation is standard deviation x bar, but it is now square root of the variance of x bar divided by n times the square root of n minus n over n minus 1. So the capital N here is the N for the population, and the small n is the sample size. So this is what the mean and standard deviation for without replacement. And previously, I've discussed that for with replacement, this is the mean and standard deviation. So the only difference here is that ang ilahang standard deviation. So sa with replacement kay wala na siya times square root of n minus small n over capital N minus 1. But in without replacement kay gani na siya variance. So this is actually simple. I think we already solved for the mx sub bar, mu sub x sub bar. The answer was 4. Katong inyong gikuha ang tables ani. And the standard deviation is 5 over 36 times what? Your capital N is kung pila sila kabuok. That is 10. Minus pila yung sample size na ipangita. That is 4. Over 10 minus 1. Yung times ha. Result ani kay 0.85. Therefore, this is your mean and your standard deviation for without replacement. So, I want to go back shortly here. This value here is what we call from the basis what? Right, let me check. Central limit theorem. Central limit theorem. Central limit theorem. It says here that if random samples of size n are drawn from a large or infinite population with mean, mu, and variance sigma squared, then the sampling distribution of the sample mean x bar, this is the sample mean, is approximately normally distributed with mean mu x sub bar and standard deviation sigma x sub bar, where you should note that the mean here is just the mu and the standard deviation here is what? Square root of sigma squared over n, or what? Sigma over square root of n. Okay, you cancel this. Then I'll continue the theorem. Hence, z is what? X sub bar minus mu over what? This is supposed to be sigma, right? Or x sub bar minus mu, in which our sigma is actually this one. sigma over square root of n is a value of standard normal variable z. So remember the table 2, katong standard normal values. This central limit theorem, mao siyang theorem na nagprove nga despite despite getting only the sample mean, the x sub bar from a population, not a new version siyang mean and standard deviation, right? But ang values ni z kay sa standard normal table lang gyapon ninyo kaon is a value of the standard normal variable z. So any values na it says here na if random sample sizes if random sample of size n are drawn from a large, meaning large or infinite population, super dako, with mean, mu, and variance sigma squared, yung sampling distribution kay na siya sampling mean instead of normal nga mu, naka mu sub x sub bar, meaning gikan siya sa sampling distribution. And the standard deviation, instead of the normal normal nga sigma, you have sigma x bar or sigma over square root of n. So mao na siya ang gimean sa central limit theorem. Okay, so I want to check if you really watch this video. I'm encouraging you all to watch this video and then answer this problem, ha? And you write your answer, you write the problem along with the answer in a 1/4 sheet of paper. So you can check with your friends na, nag-watch ka sa video nag-post ni ma'am. Kung siya, wala, ngano day, dito na pag-stop, ingna lang siya na pag-watch para pag-watch lang good para sa imong kaayuhan. So write this in a 1/4 sheet of paper and solve electric. Don't use ChatGPT first. Okay, ChatGPT can be sometimes inaccurate or wrong, and I will know if you used ChatGPT. Standard deviation of 400 hours. 400? It should be 40. Find the probability that random sample of 6 bulbs will have an average lifespan less than 775 hours. So, class, dili na mo need of, obviously, here's the problem. An electrical firm manufactures light bulbs that have a length of life that is approximately normally distributed with mean equal to 800 hours in a standard deviation of 40 hours, with a probability that a random sample of 6 bulbs will have an average life less than 775 hours. So, this is probability that what x bar is less than 775. So for this one, you don't need to do the probability distribution table. You don't need to do the ones here. Kani, di na ka kailangan magigani. Nga naman. Because you already have what? These values in the problem. Naka-ani. Nanapod ka ani. So, no need na ka mag-probability distribution. This is really simple. You write this in a 1/4 sheet of paper and submit it for Hume C, submit it on Monday, and for STEM B, submit it on Tuesday. Okay? So, I hope you understood the lesson, class. Feel free to leave a comment in the comment section below. Thank you and goodbye.